presentation of the SimBot dataset collection project. I'm Bharani and this is Lini, and both of us are working together on this project. So intelligent personal assistants grew out of this desire for having artificial agents to be able to perform tasks collaboratively with humans in a complex multimodal world. And embodied AI realizes this dream of artificial agents being able to move through the real world and affect the physical environments just as. Oh, okay. Just as humans do. And embodied conversational agents are embodied agents that are capable of engaging in conversation with humans and one another using verbal and nonverbal means of communication, such as natural language, gestures, and so on. However, existing data sets for building such conversational agents have been lacking in two major areas. The first one being they are very few in number. And secondly, the ones that are present, they fail to model interactions in more naturally occurring settings. There is absence of ambiguity, clarification, correctiveness in dialogue that we see in a natural setting. To give you an example, if I would ask the agent, can you pick up the red dog-like object on the top shelf and place it on the second shelf from the top? I would want the agent to say, hey, there is a green hand. Should I be placing it to the right of it? And based on my response of yes, I would want the agent to act. Scenarios such as this and many more are absent in the existing data sets, and this is the gap that we look forward to fill through this project. Having identified these challenges to building embodied conversational agents, we aim to build a novel data set that addresses these unique challenges and achieve a more realistic sense of grounding. And we feel that with this elevated understanding, agents will get access to information that they earlier did not. And this can especially help and manifest in technology such as assistive technologies for the disabled, as well as in situations of rescue where laymen could talk to the agent and get some help. So with that being said, we have identified two major skills that we would want a dialogue agent to acquire. The first being context awareness of physically situated dialogue, which means the agent should be able to understand references to occupancy, proximity, attributes of an object, as well as the agent should be able to adapt to language variation, which means directional cues versus high-level goals or low-level goals. So in order to do that, we aim to build a data collection platform through which we look to collect such data by simulating natural interactions through a virtual interactive environment. And we will have human participants working together to accomplish a particular task in a simulated environment. And as they do it, we will capture voice and log interaction details. And with all of this information, we will be able to rebuild the entire interaction video at a later stage using all of the captured logs. So these are the four major components in our desired solution. So the first being user pairing, simulator setup, event and voice capture, and video reconstruction. And we'll go through this in the few coming slides. Yeah.
So here are the scientific hypotheses of our project. First, the dataset should be able to build dialogue agents that can interact with humans in more natural settings and also handle ambiguities and uncertainties that appear in the conversation. And also the dataset should be able to capture the physical properties of the environment and also different levels of instructions and responses between humans and agents. And researchers and developers could use the data collection platform to collect data that meet their personal needs for building embodied AI agents. And some of the functionality that we wish to include in the data collection platform will include a robust voice over internet protocol calls, smart and automatic pairing, and also scenes with more complicated setups. And in order to evaluate the effectiveness of the data sets, we can first apply the benchmarking models on the data sets. Because the benchmarking models are not trained on the data set that includes the level of uncertainties and ambiguities that would appear on our new data set. So they should not work very well on our new benchmarking data set. And also throughout the course of the project, we would also develop some automatic checks to evaluate the quality of the data set. So here are the four major features that we want to include in the data collection platform. So first, we wanted to introduce smart and automatic peering that would automatically pair up two users that are currently logged in on the platform, and even to pair up users that are on the same level of expertise with interacting with the simulator and participating in the experiment. And second, we want to introduce the voice over internet protocol stream and recording. Because of the scale of the data sets, we wanted to ensure the quality of the audio that are captured in the experiment. And second, we wanted to introduce more advanced and more complicated simulator setups. This could include the number of rooms and the type of rooms, and also the total number of objects, the configuration of the scene, etc. And we wanted to set up all our infrastructure on cloud. This would include setting up our web application, hosting our web application on cloud, and also storing all the data on cloud. So speaking of the intended users of the dataset and the data collection platform, so for the researchers, they could use the dataset to advance their research and build state-of-the-art models for conversational dialogue agents. They could also use our data collection platform to speed up their research in collecting multimodal data, because we have already set up the platform for them. They don't have to reinvent the wheel. And for the developers, they could also use the data set that we built to develop conversational agents that could assist people in daily lives. And for the crowd workers, they mainly interact with our platform to provide us with the data to build the data sets.
So as Linny mentioned, these are the main functionalities that we have in our system. User pairing, so we need to assign two random participants to pair them up to work together. Simulator setup, so we should have a scene with confusable objects and host this over a server. Then we have the event and voice capture to capture all of their interactions. And finally, a video reconstruction component that would sort of combine all of this together. A few functionalities in terms of the data set and the collection platform. So we would want the data set to be large enough to train these models. It should include instances that have references to physical properties, high-level instructions, low-level instructions, various utterances made by humans, as well as corrective dialogue. And the collection platform should utilize a crowdsourcing marketplace so that we're able to scale this out and get the data as quick as possible. And we would like to filter participants through a qualification task to make sure to improve the quality of data we have. And we would like the platform to also be able to identify whenever a participant is cheating. And we'll also be employing a robust method to connect these participants. And we want the platform to be extensible so that future researchers can add in more configurations or adapt this platform to their experimentation. So we've highlighted them as high priority and low priority. Similarly, there are a few non-functional requirements, especially of the data collection platform. We would want it to be available, interoperable, and it should be well performant in terms of good quality audio and logging all the information we need. We would like to preserve any, the security of the user and anonymize any information we have about them, and perform a good amount of testing and integration to ensure all of the modules we have are working the right way we want. And we would like to be able to collect around a good number of samples so that we can build a good enough model with it. However, with these being prioritized, the low prioritized ones are modifiability, usability, and observability. So we will go through how we're going to tackle these as we move through the presentation. In terms of the resource requirement, since this is a data collection task, we have no prior data that we need. And we will be hosting all of the infrastructure we build on the cloud. And the crowd workers are required to have access to a desktop device, which is browser enabled with a mouse, microphone, etc., so that they can take part in the task. And the cloud servers that we have would need to meet the minimum requirements to host or run the simulator that we use, which is AI2 Thor. And the collected data that we have will undergo a manual cleaning of the test data, because we will have models being benchmarked on the test data. However, from our learnings of doing this manual process, we would like to bring in automated checks to clean the training and the development sets. So all of this that we spoke about come in with a few considerations that we've made about our design. A few assumptions are that we assume that the participants belong to the US region and have a good fluency in English. So we're currently targeting just the English language. And this would be done through the crowdsourcing marketplace that we use. And we also assume that they have the cognitive ability to interact with a WebGL-based simulator, and they abide by the instructions that are provided to them to carry out the task. And based on our learnings and readings from the earlier works, we assume that the data we collect will be beneficial in building state-of-the-art models. However, this comes in with a few constraints. The scale of the data and the quality of the data is determined by the experience level of the participants we have. And the timeline of the Capstone project would essentially, we would like to implement the high priority requirements first and then move down. And we will be employing a modular approach for design in terms of having components for user pairing, simulator setup, voice capture, and video reconstruction, and then sort of bring them all together.
So now we talk about the overview of our design. So this graph shows the an architecture of our design. So we use Amazon mTurk to randomly pair up two users, two crowd workers on the marketplace, and assign them either as human role participant or agent role participant. And both participants would participate in an online experiment. They basically interact with the WebGL-based AI tutor simulator model. The model will be hosted by Amazon EC2. It will be a web application. And throughout the experiment, the logs of the event, which basically means how they will interact with the simulator using keyboards and mouse, the actions of the events, and the recording of their conversation will be captured. And this information will be later sent over to reconstruct the experiment video. And all the data will be stored in Amazon S3 buckets. And we will use Amazon Team to do audio streaming. This is the part of the voice over internet protocol calls that we previously talked about, which would ensure the quality of the audio. And we would also use FFmpeg to reconstruct the experiment video. So apart from the crowd workers participating in the experiment, the researchers and developers could also monitor the status of the experiment and customize their configurations of the experimental setup. So the design of our data, we basically focus on the data that we will be later used for modeling. So the most important are the logs of the event, the audio of the event, and also the transcript of the audio. The video reconstruction is also an important part of the modeling process, but because these files are too large and also it's very hard to release them, so we will instead prepare a script for researchers, developers to reconstruct the video themselves using the logs and recording. So apart from the data that are used for modeling, there are also some data that are important for us to internally evaluate the quality of the data set. These include the setup information of the scene, which include the ID of the scene that corresponds to the AI tutor simulator, and also the type of the room, the number of objects, and the action space, which is the list of actions that the crowd workers could perform using keyboards and mouse, and also the instruction information, which is the instructions given to the agent and human role participants, the specification of the goal that they are going to achieve in this experiment. And the experiment information includes the length of the dialogue, the number of turns, the initial and final scene configuration, and whether their goals are achieved. So this slide shows an overview of our experiment's workflow. We will explain in more detail in later slides. So this slide shows an example of the interface given to the agent role and human role participant. So for the agent role participant, they will be given the initial and final configurations of the scenes. So as we can see from the pictures, the final configurations are different from the initial configurations. So for the agent role participant, they should figure out how to move the scenes to make sure that they achieve at the final configuration of the environment. And for the human role participant, they are not given the initial and final configurations of the environment, but instead they are given some detailed instructions on how to interact with the simulator using keyboards and mouse. So for the agent role participant, they cannot interact. And for the human role participant, they are not given the information of the environment. So it is their responsibility to communicate with each other and figure out how to arrive at the goal that's given to them. So these are a concrete example of the instructions given to both participants. So as we can see, for the agent role participants, their task is to move the highlighted object from the initial configuration to the final configuration. So these highlighted objects are referred to the objects on the table, like there are some circled objects, but it's not very clear here. So for the human role participant, they are given instructions on how to interact with the environment.
So how would we look at testing this or the design decisions we've taken? The first one is that we would have an initial pilot run of all the data that we collect to ensure, if there are any bugs in the data collection platform or the data we collect itself, all of that could be fixed. And then we would start the collection of our data. And once we have it, as I mentioned, we would manually inspect and clean the test set. And through this, we would learn automatic checks to filter the rest of the data. And we will benchmark the performance of existing baseline models with the help of the other SimBot teams to identify how well they are doing on our novel data set. The data collection platform would undergo trial simulations to ensure all of the components are interacting the way we would like them to have. And we'll ensure that we run a few simulations with the people around us so that everything is error-free. And once that is done, we'll also verify that we're able to host parallel sessions where we have multiple people taking up this experiment. And we'll also verify that there is no personal information of the participants that are collected from the crowdsourcing marketplace. So how will we be deploying the two artifacts of our project? The first is the data set. We will be open sourcing it to the public. The idea is to first get it on one of the cloud-based storage platforms and then scale out with time. And the data collection platform infrastructure would be a code-based open source through a GitHub repository. And all of this is being done with a few process risks in mind. The first one being that the faithfulness of the participants towards the task was a great quality, a risk to the quality of the data we collect. And the cost and complexities of hosting the crowdsource experiment will influence the amount of data we collect. And once we have a prototype on the cloud infrastructure, we'll be able to gauge this better. The simulator is a heavy software in terms of the computational resource, which would introduce some lag, but we feel this would not affect it to a large extent. And this is a landscape of the tools and dependencies we have. So the simulator is AI2 Thor. We'll be using Amazon Mechanical Turk to crowdsource the data. Unity is our game engine, which is on what the AI2 Thor simulator runs. AWS is our cloud platform. We use WebGL, FFmpeg, Apache to sort of build up our web application. And this is the landscape of our dependencies. And yeah, these are the list of tasks that we'll be working on.
So first, we, at the start of the project, we make sure of our domain and domain statement and consult with our mentors. And next, we build our data collection platform infrastructure, which includes all the components in the platform, the AI2 Thor simulator, the crowdsourcing marketplace, the cloud-based servers, Amazon team for audio streaming, and also set up new rooms in AI2 Thor simulator. And in the data collection process, we would first build our first prototype data collection platform and conduct first stage data collection this makes sure that all the components in the platform runs as expected. And also we wanted to use this to collect a small sample of data to analyze and make some further changes on our experimental setup. And we would extend the settings of the AI tutor simulator depending on the result of the first stage data collection. And then we will wrap up our data collection platform. And the data collection platform should be able to collect 5,000 samples. And we will also conduct the final stage data collection. So in the data benchmarking, we would internally evaluate our data set using the automatic checks that we built throughout this project. And we will prepare the data set for release and modeling, especially the data that are important for the modeling, just we talked about. And finally, we will submit our research and our final report. So here's a milestone plan. So we are currently on the building data collection platform stage. So in terms of the completed task, we have written several documents, and also we set up the AI tutor simulator, trying some room setups. And we also set up infrastructure for the pilot study, and both locally and on cloud. This include a Flask application for user peering and a web RTC for audio streaming. And we are currently researching on game server hosting for multiplayer games because we are migrating to the data collection platform stage. So this is basically the end of the presentation. Yeah, thank you.
Thank you.
Can you go back to the reflection slide? I don't want to just skip over that. That might be something interesting. Yes, I think this is a fair point because I'm still not sure that I understand everything in SimBot. Never mind, your specific part has a lot of pieces. And so, yes, I think it is, you are making a good sort of attempt at explaining all the parts. But I think you could improve on talking about how the different pieces of infrastructure actually support what you're doing. A common way to do that, and I'm remembering like the Asai team in the last couple of years, what they did was they showed their sort of architecture and workflow diagram, and then they put the logos of the different technologies. So that's probably the right way to do it. Because if you just throw up a slide that says tools and dependencies, now I'm worried it's just two of you and there's a lot of work to do on integration. So I think that is still sort of a risk for you guys. Basically, you have an integration risk because you're depending on bringing all these things together for your specific use cases. And so I think the one reflection that I didn't see, and this is probably because you just had too much stuff to handle, would be like we should have done a complete hello world system in the very beginning. And I think you're trying to do that. You just have a lot of things to integrate.
Yeah.
Also, I think probably it took you a lot of time just to understand the requirements to get to this point that you're at. I think in general, when we do one of these Amazon challenges as a capstone project, there's always a fear on the part of the faculty that the students will spend too much time engineering and integrating with frameworks and not enough time doing the actual sort of research that they wanted to do. So that's why I'm making those comments. But I'm not seeing any signs that you're not dealing with this well yet. So I don't want you to take this as a negative reflection. It's just sort of sharing with you the things that I think about. Listen to your presentation. So some specific comments. I think that clearly you have an idea of phasing and data collection and you want to do a pilot and figure out what's going on. But your focus seems to be mostly on finding bugs in the system and the software. And I think that whenever you do anything with crowd workers, there's another big issue that you have to think about. You alluded to it a little bit when you talked about the faithfulness of the crowd workers. But even people who are trying really hard, to do a great job can give you data that are less useful. So here's what I mean. You have to think about training. So you're not going to sit somebody down and have them actually do the task for the first time and then collect that data, because there's basically a training effect. Okay. You don't want to have data in your system that were done by people who understood the interface 100%, and then we're really focusing on the task, as well as data in there from people who are struggling to learn the interface, because then the dialogue is going to be about, damn, what fun do I do? Stuff. Okay. So what I didn't get a clear picture of from you guys is sort of whether you're going to have like a training regimen or like 2 or 3 training tasks for people so that they kind of get the hang of it before they go to the actual live task. So if you haven't considered that, maybe think about doing that, because I think that's one of the things that you're going to find is that not every dialogue turn and every dialogue is going to be about getting the task done, unless the interface basically fades into the background. People really another thing that's going to happen is there are priming effects. So the more people do something, the better they get at it. But then they may start doing things in a very rote way to get through it, in a way that sort of narrows the variation that you see in what they do. So it might be interesting to think about whether you care about this or not. You might not, and it may not matter that much because of the simplicity of what you're doing. But in other user studies, the sort of priming effects are considered kind of important, especially with crowd workers who start to sort of game the system. They might not sort of end up having a dialogue. They might just like quickly do something in order to get their money. So you want to think about that too. I think the random pairing is good, but then you also mentioned this idea of like what the personal goals are of the person collecting the data. Okay. So essentially you might want to have different ways of picking who's the agent and who's the human mentor. And you may not want to just rely on random sampling for that. You might want to actually sample from a specific kind of non-random distribution that you're thinking about there. Also, I think saying that you want to handle any desires of the end user is pretty strong, because you haven't said anything to us about how you're going to represent those, and then how well you're going to measure whether you achieve those. So I think it's a nice general statement to put in there, that you want to be as flexible as you can so that anybody can use this to do any kind of experiment. But I think you probably want to, for your final presentation, maybe dial back a little bit on that and say what you think is actually possible for this. So I think most of my concerns so far have to do mostly with the process of doing the data collection rather than the product or the system. Because even if you develop this exactly the way you're intending to, it's perfect, no bugs. Now we have this question of, okay, how do we kind of get the data out? I think that you didn't share too much about like the variation that's going to happen in the actual simulations. And that would be the thing that I would be kind of drilling down on the most. Is there anything about any of these simulations that's going to trip up the Turkers so that this one, they'll find particularly hard, right? So it could be that the description of the user interface is great for these 3 simulations, but this one somehow has a different, spatial orientation such that people won't understand, what it means to go forward or something. I'm making that up. Mm-hmm. So you probably want to think that through. And then obviously, if you're going to do a pilot, don't just do a pilot on one of the simulations. Make sure you do a pilot on all of them. Mm-hmm. you want to think about how to shuffle the users around. So it might be that you want to have people, if you're going to have repeat Turkers, have them be the user and have them be the agent, but then you're going to want to maybe flip them around so that, if you were going to submit a Chi paper on this, you'd have to literally look at what's the priming effect of, being the agent first and then being the mentor, or vice versa. It's really expensive to only use a certain Turker for one thing and not the other. You kind of eliminate any crosstalk, between the experiments if you do that. But it is a way to kind of eliminate them, a priori. It may be that you decide you don't care about this, because really what you care about is the quality of the data that are generated. And then what you can say is, we're not going to worry at all about any of these user study effects, because in reality, we're just going to analyze the dialogues for realism. And if they look real to us, we're not going to worry that, one was generated by somebody that, had already done a ton of agent, simulations versus somebody that had. So it kind of, so the thing is, you don't want to make claims about what the platform is doing for you unless you're actually going to measure them. So you can decide how you want to deal with this feedback. And it may be that what you want to do is say that you're not going to delve into that at all for this first round, and you're going to focus mostly on gathering data and then evaluating the quality of the data by training models with the data and then seeing what happens. Although you realize that these are effects that someone might care about downstream. So, and talking to any of the faculty, on the HCII side who have a lot of experience in developing, user studies, Professor Stanford or Professor Rosé, speed on this. But my guess is that you have enough to do that I'm going to leave it at this and just sort of treat this as you've got a little bit of a side education on these things. But make sure that if you're not going to worry about those kind of priming effects or user selection effects that you explicitly say, you're not.
Yeah.
So did you guys talk about that at all in your team meetings?
We did actually. Professor Yonatan mentioned like his lab has sort of acquired a user base of Turkers that actually work on almost the frequent experiments they release. So they said we could release it to them initially, and we would know authentic feedback as to what, because they know they trust in their process. So they say that we would release it to them, and then based on their feedback, we'll make modifications and move forward. But as of now, we're sort of figuring out how to bring all of the components, like you mentioned, the infrastructure itself. But he mentioned that as we're planning on looking at it through the summer as well, so that we have some heads up with Turk and MTurk and stuff. So because it's something that we've never worked with and we wanted to make sure. So I think we should be digging into that.
So are you guys going to do this for your internship or just as a separate task while you're doing?
Yeah, just as a separate task. Yeah, during the summer.
Good enough. Just be realistic, about how much you can manage.
Yeah.
You have to have a life.
Yeah.
As well as, the internship.
Yep.
And this work.
Yep.
So another thing I think you could improve is normally when we have a project about a data set, one of the first things we see, in addition to the motivation, which I thought was fine, you had a nice example. One of the first things we usually see is a schema. So here's what the data set looks like. Here's what each data element is going to look like. That's this part and this part and this part. And we're going to represent it as, this kind of JSON, where this thing is going to be a pointer to, a data file in S3 or something. Presumably you guys have been thinking about that and you just didn't, include that here. Make sure that you put that in, obviously, in the final presentation. One thing that wasn't quite clear to me was it seemed like there was some design decision about whether or not you guys were going to actually create all the reconstructed videos or just release the scripts that the scientists could use to create those. So which one is it?
So initially, how we thought of this was the pilot study that they had earlier was they were on a Zoom call. So both of them, the human and the agent would be on a Zoom call and they would record the screen. But now we came to understand that it's very heavy on the system to run the application and the Zoom call. So we decided to log every single action on the simulator, and we have been able to build a script that reconstructs the entire video. And then we would use FFmpeg to align the audio with the video. So that's
So you are going to.
yeah, we are.
Okay, great. Very
Yeah.
good.
Yeah.
So I think really the only thing you want to tune up in the presentation is focus more on the data set rather than
Yeah.
the collection system.
Mhm.
It's very clear right now that you're focusing really hard on getting that system built because you think that's like the biggest challenge here. But, you know, we want to know things like how many instances are you planning to collect and all of that stuff, you know, show an example.
Mhm.
And I'm sure you'll have time. to
Yeah.
put that together.
Yes.
Liam, did you have any questions for the team?
I have a comment about the evaluation. I think for common data collection projects, it will run some baseline model to evaluate the quality of data set instead of manually expand. I think you also mentioned this in the report that you're going to use the other teams.
No, yeah.
Baseline. However, you can include it also in the presentation.
Mhm.
And also you said the data set could have multiple layers of information included. So during evaluation, you possibly could include how the workers reflect each layer of information.
Mhm.
Yeah, and I guess you could go even so far as to like creating your own leaderboard too, right? So if you literally have a dialogue modeling task, then, you know, the two of your groups to kind of come together and then literally release the data set and release, you know, the baseline. I guess since it's part of this overall challenge,
Mhm.
you don't need to do that. So maybe somewhere in your write-ups, you can say that we're following, you know, typical best practices for the release of a new data set baseline model and sort of metrics for a leaderboard. However, since it's part of this existing challenge, we're not going to, you know, create a website or do anything like that.
Yep.
Great. Thanks, guys.
Thank you.